Hello and welcome to helpyourmath.com. In this video, we're going to look at examples of applying right triangle trigonometry. So we're going to be looking at examples of finding trig values of right triangles. Let's just quickly review what those trig values are for right triangles. So we have 6 trig functions. The first one is sine. Sine of theta is equal to what on a right triangle? It is equal to the opposite side over the hypotenuse. It's a ratio, right? All of these are ratios. Cosine of theta, that is equal to the adjacent side length over the hypotenuse. Tangent of theta, where theta is our angle measure, this would be the opposite side length over the adjacent side length. And the inverse of sine is cosecant. Cosecant of theta is hypotenuse over opposite. The reciprocal of cosine is secant. Secant of theta is equal to the hypotenuse over the adjacent. And lastly, the reciprocal of tangent is cotangent, and that would be adjacent over opposite. So once we know one measure, we can figure out all the other measures based on these ratios, and if we are missing a side, we can always apply Pythagorean theorem to figure out the missing side length. Let's look at some examples. Find the missing side length, then find the 6 trigonometric functions for angle A. Since this is side length A, that indicates to us that angle A is over here. Okay, and we are missing the value for A, so here is our hypotenuse, and this would be the side that's adjacent to A, so I'm just going to label these. This would be the side that's opposite A, and we're also missing that. To figure that out, we'll do Pythagorean theorem, A squared plus the other leg squared is equal to the hypotenuse squared. And this would be A squared plus 36 is equal to, let's be careful here, 3 squared, we need to distribute the square. 3 squared is 9. The square root of 5 squared is 5. 9 times 5 is 45. Now we want to get A squared by itself, so we're going to subtract 36 from both sides. And we get A squared is equal to 9. Now we want to take the square root of both sides. When we take the square root of the numerical side, we should add a positive or negative in front of it, but because we're dealing with side lengths of triangles, we can disregard the negative. Triangles must have positive side length measures. So we can disregard the fact that we would have a negative square root of 9 or negative 3, and our missing side is 3. Okay, so now we're ready. We have all 3 sides. We can figure out that sine of A, remember sine of A, that's opposite, which is 3, over the hypotenuse, 3 times the square root of 5. Now, a few things here. You should rationalize the denominator. You shouldn't leave a irrational in the denominator, right? There's whole lessons about this. So that's what we want to deal with, number 1. Number 2, if we can simplify, we should simplify. So what I notice here is that there's a factor of 3 in the numerator and a factor of 3 in the denominator. So that would leave me with 1 over the square root of 5. Now to rationalize the denominator, I need to multiply by the square root of 5 under the square root of 5, right? I'm multiplying by a factor of 1. And this will give me the square root of 5 over root 5 times root 5 will be 5. So sine of A is the square root of 5 over 5. How about cosine of A? So cosine of A, that's adjacent over the hypotenuse. And again, if we can simplify, we should. 6 and 3 do have a common factor of 3. It goes into 6 twice. It goes into itself once. And we need to rationalize this denominator. So we're going to multiply by the square root of 5 under the square root of 5. In the numerator, that's going to leave me with 2 radical 5. I don't know why my computer does this, but it does. I'm going to have to put the answer over here just because it should work over here. Yep. Over root 5 times root 5 is 5. And we can't simplify that, right? Because this 5 is a normal 5. This is a square root of 5. Those we don't simplify those. They don't have any common factors. Okay, last of our main functions, we have tangent of A. That's opposite over adjacent. Much better. Oh, that's a nice one. We can simplify this. This would become 1 over 2. All right, we're halfway done. I don't know if the computer, well, let's see. Oh yeah, it works just fine over here. Next we want cosecant of A. That's our reciprocal function of A. So you can either think of it as the reciprocal of what sine A was, or you can know it as hypotenuse over opposite. What I would suggest is that this one you won't need to rationalize the denominator because the irrational part is going to be in the numerator here. So I would go back to where we simplified it right here, and that's where I would take the reciprocal, or just go back to the triangle and do hypotenuse over opposite. So this would give us, if we take the reciprocal, that would be root 5 over 1, which is just the square root of 5. If you use the end result, the root 5 over 5, then you would have to rationalize the denominator again, and that's just more work. So don't make more work for yourself. Go back, either use the triangle itself or use the before you rationalize the denominator and sign. All right, the reciprocal of cosine is secant, and secant of a, and again, same thing. If you're going to use the fact that it's the reciprocal of cosine, go back to right here where we had 2 over root 5, and you can rewrite it as root 5 over 2, and then you're done. And the reciprocal of tangent is cotangent. Cotangent, we don't need to worry here. You can use this nice simplified one. That would be 2 over 1, which is just 2. So these would be the 6 trigonometric functions for this right triangle. Okay, how about this right triangle? So I always encourage you to pause the video and try this on your own, and then check back with me. The first thing we need to do is let's label where A is. So A is going to be over here in this corner. And now we need to figure out the value of A. So here's A, so this is the side opposite of A. This is the side adjacent to A, and this is our hypotenuse. The hypotenuse is always opposite the right angle, so that's how we know which one's the adjacent side versus which one's the hypotenuse. Now we need to figure out the value of A, so we're going to say A squared plus 3 radical 2 squared is equal to 2 radical 7 squared. Distribute that square, so 3 squared is 9, and the square root of 2 squared is 2. 9 times 2 is 18. Over here, distribute the square. 2 squared is 4. The square root of 7 squared is 7. 4 times 7 is 28. Now get A squared by itself, so we'll subtract 18 from both sides, and we get A squared is equal to 10. Take the square root of both sides. Normally we would put that plus or minus, but we get to disregard the negative since we're talking about triangles, and we end up with A is equal to the square root of 10. Looks like we're going to have lots of rationalizing with this one because every side length has an irrational piece to it. Okay, now our 6 trig functions. So first we're going to look at sine of A. That's opposite over hypotenuse. And we need to rationalize the denominator. The irrational part of the denominator is that square root of 7. So I'm going to multiply by root 7 over root 7. And this is going to give me the square root of 70 over, this is 2. And root 7 times root 7 is 7. 2 times 7 is 14. We cannot simplify this at all. The square root of 70 doesn't have any perfect square factors besides 1, and the 14 is not under a radical where the 70 is, so this would be sine. To determine cosine of A, let's see, that would be adjacent, 3 root 2, over the hypotenuse, 2 radical 7, and again we're going to rationalize the denominator, multiply by root 7 over root 7, and this will give me, in the numerator, the 3 is the only rational part of the numerator. Root 2 times root 7 is root 14. In the denominator we have 2, and then we have root 7 times root 7, which is 7. 2 times 7 is 14. I'm not going to be able to simplify that, so we'll move on to tangent of A. Tangent of A is going to be opposite root 10 over adjacent 3 root 2. And now you have a choice, because before you jump to rationalizing, which is a good thing to do, we don't need to, because root 10 and root 2 have a common factor. They have a common factor of the square root of 2. So I can divide the numerator by the square root of 2, which will leave me with the square root of 5. And I can cancel out the root 2 in the denominator, leaving me with just that rational 3. Then we don't have to go through the motions of rationalizing the denominator because we just did, it just rationalized. If you did, and you multiplied by root 2 over root 2, you're creating a little bit of extra work for yourself, because then you would have to simplify the square root of 20. So it's just a little bit more work. So look before you rationalize to see if you can simplify first, which we were able to do, and that kind of saved us some time. Okay, now we're looking at the reciprocals. So we have cosecant of A, which, let's see, I'm going to use this one here. So it's going to be the reciprocal of that, so it's going to be 2 times the square root of 7 over the square root of 10. Then we're going to rationalize this by multiplying by the square root of 10 over the square root of 10. And that's going to give us 2 times the square root of 70 over 10. And now we have one extra step because 2 and 10 have a common factor. And that would be, they both are divisible by 2, so I'm going to divide them both by 2, and we end up with the square root of 70 over 5. So this is our cosecant A. I'm just going to put a box around it. Next we have secant of A. So secant of A, that's going to be the reciprocal of cosine. I'm going to go back to right here. That's going to be 2 radical 7 over 3 radical 2. The irrational part of the denominator is that root 2, so I'm going to multiply by root 2 over root 2. This will give me 2 radical 14 over 3 times root 2 times root 2. That's 2. 3 times 2 is 6. And look, we can simplify again. 2 and 6 have a common factor of 2, so this will become the square root of 14 over 3. And last but not least, cotangent. So cotangent of A is the reciprocal of tangent. I'm going to use this one right here. Or why not just use this one? Forget what I just said. Let's save ourselves one step. So this will become 3 over the square root of 5. Here we do have an irrational denominator, so we're going to multiply by the square root of 5 over the square root of 5, giving us 3 root 5 over 5. Whew, that was a lot of work. How else can we be asked to find these trig functions? Well, we could know just one side and then have to find, one trig ratio, and then have to find the remaining trig ratios. So this encourages us to sketch a diagram of the right triangle, so we'll do that. And we have beta here, so I'm going to put beta down here. It doesn't, as long as it's one of the two acute angles, it doesn't matter which one you assign to beta. Now, what does tangent tell us? Tangent tells us the opposite side and the adjacent side. So I'm going to label opposite is over here, and that's 4. And adjacent is right here, and that's 7. Okay, so now I know two sides of my right triangle. What about the third side? Well, I'm missing the hypotenuse. So what I know is that 4 squared plus 7 squared equals the hypotenuse squared, or you can use c squared. This would be 16 plus 49 is equal to h squared. 16 plus 49 is 65. That'd be 65 equals h squared. Take the square root of both sides to get rid of that. We should have this plus or minus, but again, we disregard the minus, and we end up with the square root of 65 is equal to h. The square root of 65 does not have any perfect square factors besides 1, so we'll just leave it like that. And now we have all three. So now it's just like the example we just did. We just had an extra step at the beginning, and that's using the information from the ratio we're given to figure out what the side lengths are with respect to that. So now we can do sine of beta. Sine is opposite over the hypotenuse. Eek. And we need to rationalize the denominator, so we're going to multiply by the square root of 65 over the square root of 65. That's going to give me 4 radical 65 divided by 65. Cosine of beta, that's going to be adjacent, which is 7, over the hypotenuse, root 65. And we're going to do the same thing. Multiply by root 65 over root 65. We get 7 radical 65 over 65. Tangent, I think, is going to be rational. Hooray, hooray. Tangent of beta, that's opposite 4 over adjacent 7. And we can't simplify that, so it would just stay like that. Okay, now, we didn't need to do a tangent. Duh, it was given to us. Haha, I just did extra work. Now we need the reciprocal functions. We have cosecant of beta is the reciprocal of sine. I'm going to use this piece right here. The reciprocal of 4 over root 65 is root 65 over 4, which we don't have to do anything further. The reciprocal of cosine is secant. Secant of beta, I'm going to use this right here. The reciprocal of that will be root 65 over 7. We have a rational denominator, so we don't need to worry about secant. And cotangent of beta, we could have actually figured out cotangent without ever drawing the triangle, because it would just be the reciprocal of tangent, which would be 7 over 4. In our last example, we know that cosecant of beta is equal to 3. Wait a minute. These are supposed to be ratios. 3 is not a ratio, but we can turn it into a ratio by putting it over 1. Now that I've given you that hint, I always encourage you to pause the video and try it and see how you do, and then check back with me. Alright, so first, what does cosecant tell us? Well, it's the reciprocal of sine. So it's going to tell us the value of the hypotenuse and the value of the opposite side, or the length of the opposite side. Let's draw our right triangle and get a better look at this. I'll put beta down here again, and the side opposite beta is over here, so here's my opposite side. And my hypotenuse is up here. So I'm missing the adjacent side. How can I figure out the adjacent side? That's right, Pythagorean theorem. So what we know is that 1 squared plus our missing side squared is equal to 3 squared. 1 squared is 1, a squared stays a squared, 3 squared is 9. Subtract 1 from both sides, we get a squared is equal to 8. Take the square root of both sides. We can forego the plus or minus, or the positive or negative, because we're talking about triangle lengths here, so there's no negative triangle lengths. And we end up with a is equal to the square root of 8. Before I go any further, 8 does have a perfect square factor. So before I insert this into my triangle, I'm going to simplify the square root of 8. 8 is 4 times 2, and 2 is a perfect square. So we can rewrite this as the square root of 4, which is 2, times the square root of 2, which is the square root of 2. Okay, so my adjacent side is 2 radical 2. Now we're ready. So we have sine. Now sine, I actually didn't even need to do the triangle because I know that sine is the reciprocal of 3, and the reciprocal of 3 is 1 over 3. I can check my work with my triangle to make sure that opposite over hypotenuse is a third, and it is. Cosine of beta, that's going to be the adjacent 2 radical 2 divided by 3. Since the denominator is rational, we can leave it like that. And tangent of beta is going to be opposite over adjacent 2 radical 2. We do have an irrational in the denominator, so we want to turn that rational by multiplying by root 2 over root 2. We don't need to multiply by 2 radical 2 because 2 is already rational and it's going to stay rational no matter what. When I multiply by the square root of 2, I get the square root of 2 over 2, and then root 2 times root 2 is also 2, a factor of 2. 2 times 2 is 4. So tangent of beta will be the square root of 2 over 4. For our reciprocal functions, cosecant is already done and I'm not going to repeat it like I did with tangent. So I'm going to skip cosecant, we'll go straight to secant. Secant is the reciprocal of cosine, that will be 3 over 2 radical 2. Let's rationalize the denominator by multiplying by root 2 over root 2. And we end up with 3 radical 2 over 2 times root 2 times root 2 is 2. 2 times 2 is 4. We can't simplify because 3 and 4 don't have any common factors besides 1. So that's secant of beta. And last but not least, we have cotangent of beta. Cotangent will be the reciprocal of tangent, or it would be adjacent over hypotenuse. I'm going to use this hypotenuse, adjacent over opposite. Good Lord. Cotangent is adjacent over opposite. If I use right where I just drew that arrow, it would be 2 radical 2 over 1, which would just be 2 radical 2. 1's rational, and we can drop it because it's an identity. So that would be our cotangent. These have been examples of looking at the trigonometric functions of right triangles. Thank you for stopping.